So our solution is, well, we find our solution by writing this as dv over v equals negative gamma over m. dt, and I'm skipping a step here, but we're very used to that step and we've seen it many times. So we get natural log of the absolute value of v equals negative gamma over m t plus a constant, which again leads us to v equals a e to the negative gamma over m t in a process that we've dealt with in complete detail and should be very familiar. And if it isn't, make sure that it is before you take the test. Okay. Now, we know that we'll choose our time such that v of 0 equals v naught. We'll measure our time from the instant when we start, okay? From the initial instant, okay? Now we don't have to do that. We could set the time equal to 10 million at this instant, okay? But this is the simplest because then we have v then equals v naught e to the negative gamma over m t. Now this says, actually I don't think I gave you any specifics on this. Okay, so we say what's the value of the drag coefficient? I end up with an imperceptible velocity after traveling distance s. Okay, that's the way it's stated. Now it says that it gives you the time at which you get to this point, okay? And actually, that time is close to infinity, simply because at that time there's no perceptible motion, so there's no perceptible velocity, and this velocity becomes imperceptible as t approaches infinity, right? So for the situation where the drag force is proportional to v and you get this exponentially decreasing velocity, the time t at which you reach this position is pretty much irrelevant, okay? That time you just consider to be, well, that time, that's a long time, that's infinite time. Okay, so the question then is, how far do I travel in infinite time, right? So the total distance then has to be close to s. That looks like AST there. I didn't leave myself enough space, so I'll use some parentheses. Okay, must be close to s. That means s is the integral from 0 to infinity of v of t dt. And of course, then this is the limit as, say, tau goes to infinity of the integral from 0 to tau. And antiderivative of this is m over gamma, negative m over gamma v naught. Okay? So, again, without going through the details of that integration, that's a very straightforward integration. That's going to be negative V naught M over gamma e to negative gamma over M T evaluated from 0 to tau. Just going through the details. And this is not tau, this is gamma. My gamma looks a lot like a tau, and I just read it that way. This is a gamma. I don't think I've ever confused a gamma with a tau before. I've confused it with birds and flight. Okay, anyhow, that'll be e then to the negative gamma over m times tau. And I'll use an extra set of parentheses here, minus e to the negative gamma over m times 0. Well, clearly, as tau approaches infinity, this approaches 0. And at 0, this is 1. So this is just negative v naught m over gamma. Now we want to check to see if this is dimensionally consistent. Well, I'll leave that to you. V naught will be in units of length over time. M will be in units of mass. And gamma will be in units of force over velocity. So, check the units. In general, you want to think units of distance over time times units of mass divided by units of force, which are units of mass times units of acceleration, etc., divided by units of time, right? Or, I'm sorry, units of velocity, which is length over time. Or if you want to just put it in your familiar SI units, meters per second times kilograms, divided by newtons, which is kilogram meters per second squared, divided by meters per second, right?
If that's a negative exponent on tau, wouldn't it be approaching 0?
Well, no. This approaches 0, yeah.
Yeah.
This approaches 1.
So it'd just be -1
Yeah,
eventually.
but then you have a negative here, which I
Okay.
kind of neglected when I
Okay.
wrote down the negative here. Okay?
Yeah.
So there we have it. Okay? Now, this assumes that you have enough information in the first place to do something with this. In other words, if I know S, well then S equals this. So S equals V naught M over gamma. And that implies that the gamma is V naught M over S. And another way to check your units is just to say, well, I know the units of this, this, and this, and they're all very simple. That's like kilograms, that's like meters per second times kilograms. So I have kilogram meters per second divided by meters, okay? Which is then kilograms per second. And is that a unit of force over mass? Force over distance, okay? Well, that's kilogram meters. Well, you can work that out, okay? I don't want to get into that because that's very easy to do, and you should check the units on this one. Okay? So there are my units on gamma. If S equals 4 meters, then what's gamma equal? And let's let V naught equal, say, 2 meters per second, because gamma is going to depend on both how far I coast and how fast I was moving when I began coasting, right? So if we have this, then what's the value of gamma?
I need mass.
We don't know what mass is.
Yeah, okay. Okay.